one way to think about problem 1 is that because we have a fraction there, there is a top and a bottom. And that's a good way to think about this because we also have m to the negative 10, n to the negative 4, and we know a rule. I'll just kind of write it over here. If you had something like m to the negative 10th power, that this means the same thing as 1 over m to the positive 10th power. Okay, so that's a rule that we had to remember about negative exponents. And I think I first demonstrated that to you guys with something like 1 over 10 to the 1 power, which is 1/10, right? And you know 1/10 as a decimal anyway is 0.1, okay? And that would be the same thing as 10 to the negative 1 power. Make my equal sign a little bit bigger. So 10 to the negative 1 power is the same thing as 1 over 10 to the positive 1 power. They both equal 0.1, so you kind of know it's a tenth. Yeah, so this is one way to kind of think about this problem is in terms of a top and a bottom of the parenthesis of a fraction. 6 is on the bottom. I see that now. I have a parenthesis with a bunch of stuff in it on top. I'm just going to write that parenthesis for now, to the 4th power. And I have an m to the negative 10th, but I'm just going to instantly put that as an m to the positive 10th on the bottom of my fraction, and an n to the positive 4th power on the bottom of my fraction. And therefore, on top, all I have left is this negative 4 thing in parentheses, m squared n. And I can continue with that just a little bit further because I can distribute, my parenthesis has that 4th power, I can distribute that with all the exponents of the stuff inside the parenthesis. Please don't multiply 4 times 4, that's the biggest mistake. Negative 4 times 4, you do not do that. But you have actually the negative 4th in the beginning to the 1st power multiplied by the 4th. So we have 4 times 1, 4. So we have negative 4th to the 4th power. If you do that on your calculator, make sure you're using parentheses because you have negative 4 times negative 4 times negative 4 times negative 4. You have 4 of them. Okay, I think that's going to be 256, and I think it's going to be a positive, so it stays on top. It's not a negative. We can copy over the stuff from the bottom if we want. 6m 10 n 4. Whoops, can I make it? I'll make it 1 there. Okay, and we have an m squared times this one here. Let me see if I can do it. Yeah, we have the m squared times the 4 times 2 is 8. So m to the 8th, n to the 4th. M to the 8th, n to the 4th. So we have extra m on the bottom, 2 of them, and we can cancel out the end of the 4ths. So we have m squared on the bottom. We have 256 divided by 6. It's going to be a decimal, but they're both even numbers. Can we divide both of them by 2? I mean, you know, so 128 over 3, is that right? 128. Do that on your calculator if you're not sure. Yeah. Okay. So that's problem 1. Little bite-sized problem. How about this one? We're just adding, so we don't even need the parenthesis anymore. Add like terms. And we did the review on that, so you should be good for that recently. We were working on that. This one here, common mistake is when you're combining like terms and everything else, if you get rid of the parentheses like you did on number 2, without thinking about changing the sign of everything in this parenthesis, you would be kind of in trouble. Every single thing in this parenthesis, even this first one, the 5, gets changed into a negative 5, okay? So that's something you need to think about. And this gets changed into a negative, and this gets changed into a positive, and this gets changed into a positive. So, and then we can combine like terms, put things together that should be together, the same you did in problem 2. Here, you have something cubed, and you have this negative 2y multiplied by, think about it like this. The negative 2y is multiplied by the y minus 1. So I'm going to do negative 2y times y is negative 2y squared, and negative 2y times a negative 1 is a positive 2. Okay? So we have that to deal with. And then, because we're not multiplying anything here. We're not multiplying this first parenthesis times anything. So what is that first parenthesis? The y plus 4. So we have to know how to expand that. And one way we learned to expand that, one way we can expand that is y cubed. Or y plus 4 times y plus 4. If we had y plus 4 squared times another y plus 4, we know that that's the same thing, right? This might be easier for some people, okay? So if we have a y plus 4 squared times a y plus 4 to the 1, that's y plus 4 cubed. Y plus 4 squared, we already know, is y squared plus 8y plus 16. We already know that that's y plus 4 squared. If not, then you need more practice foiling, okay? And then we just multiply that by another y plus 4 in the front. So if I do that, it looks like something like, multiply these together, something like this. Y cubed plus 8y um, 8y squared, sorry, plus 16 times y, 16y, right? And then we have the 4 times y squared, 4y squared. I'll line it up with this one so we can add them together easily. We got like terms lined up under each other. 4 times 8 is 32y. Right, 32y. And then we got the 4 times 16, which is 64. 64. So that first part is y cubed. I'll add it together and put it right up here next to where it should be. Y cubed plus 12y squared plus 32 and 16, 42, 48y. 48y plus 64. I'll put the plus 64 on the end here. Okay, because it goes with that 2 kind of. So, you know, again, if you don't know your expansion with if you don't know how to do instantly the 4 plus y plus 4 cubed, you may have to do all that work on a separate paper or something like that, okay? So we got that. Now, we can put stuff together. So y cubed, I think I got squareds, 12 of them minus 2 of them. I think I got just 48y. And then I've got 64 and 2 is how much? 66? So that's what that looks like. This one, you got to multiply the 3k times those 3 and the negative 6 times those 3 and put like terms together. This fraction, well, you got to see if there are, for example, it would be great if there are definitely some 8s in everything on top, and I see that there's 1 8 here, and there's 7 8s there, and there's 3 8s right there. So I can put I'll just do the first one first, okay? So 8 into 8 is 1, so we've got negative 1. C squared, C6, there's a C4. D3 left on top, D3, because there are 3 extra D's on top that are not on the bottom. Plus 8 goes into 56 7 times, okay? And then we have C, couple of C's left on top. And we have a D left on top. Minus, excuse me, 8 times 3 is 24. C squared's gone, D's gone. So there's my answer. That's a 7. Kind of weird. You need to know these or write them on your formula card. That's fine with me. Okay. Factor each polynomial completely. So is there something that's the same? I think there's a 3 in both of them, and there's a couple of x's in both of them. What's left over? Another 3, because 3 times 3 is 9. Another x, because x squared times x1. And then I got 3 times 7 is 21, and x squared is gone. There we go, factored completely. Hallelujah. There's a 3 in both of them, probably. Let's try it. N to the 4th minus, divide that by 3, 443, is that right? No. 4 is comes through 120. Okay, so it is 49, okay. 49. And I see if I can continue, and I think I can, because it looks like those are part of a difference of 2 squares. The format that looks like that, which is a minus b times a plus b. And then we got other formats we can look at later. So this is going to give me a plus b, a minus b. What's my a? I think it's n squared. What's my b? 7 times 7. Okay, so n squared plus 7, n squared minus 7. At any time you can stop this video, and it's a good idea to try things on your own if you're really being smart about this. And I always want to double check in the end. It's always a good idea to double check, can I continue to factor anymore, or am I finished? We don't have any rule for n squared plus 7. We don't have any rule at all for sum of squares. We have a rule for sum of cubes, but sum of squares or anything like that, no. And 7 isn't even a square, so it doesn't even matter. But if we had n squared plus 9 down there, you still couldn't do anything with that. Now we have an n squared minus 7. Well, that fits this rule a little bit. It has the minus, and it has the n squared, but it doesn't have the b squared part. You don't have something there like a 9, which will be 3 times 3. 7 is not a perfect square. Can't go any further. If there was an n squared minus 9 there, you would have to keep going a little bit further and copy down the other stuff. And make sure you don't forget to copy everything down. Okay? So there's that. All right. We can definitely divide out a common factor here, and then we'll have some a cubes and some b cubes in there. We're going to end up using this right here, which is a minus b times a squared minus plus ab plus b squared. And if you FOIL those out, you would get a cubed minus b cubed if you multiply them out. So you would use that rule because you're going to end up having a difference of cubes. Or actually, you can use it the way it is. You don't factor anything out of that. You have 8a is your a, because it's, I'm sorry, not 8, 4a, because 4 times 4 times 4 is 64, right? And the b is the cube root of 343, which is 7, because you have 7 times 7 times 7, right? So you get 7, and b. So if you follow your formula above for the difference of 2 cubes, you're going to have this little parenthesis in the big one. This is where you use SOAP. Okay, same opposite. So same a, 4a. B is 7b in this case. And then we have our a squared, which is 4a times 4a. 4a times 4a. We have our plus AB. 4 times 7, 28 AB. And we have our, make a little bit bigger space. We have our B squared, which is 7B times 7B. Okay, that's how to do number 9. And yeah, this is getting to be a long video, so let's call this good for now.